4.5 rational functions. The objectives here for a rational function: find the domain and the graph of the function, identify all the isotopes, solved applied problems involving rational functions. A rational function, it's a fraction. A rational function is going to be a function that's written in a fraction form. That is a quotient of two polynomials, where in this case here, P of X and Q of X are polynomials, and where Q of X is not the zero of polynomials. Basically meaning that Z of X cannot equal 0 because it's in the denominator. If it equals 0, then we have an undefined function going on. Okay, so here we go. They said, well, what is the domain of this function? Well, to determine the domain of this function, I'm going to take the denominator, since it's a fraction, and set it not equal to 0, solve. And now I know that X cannot equal positive 3. Well, if I plug in positive 3 here, I get 3 minus 3 is 0. So this is a true statement. This tells me that at where X is positive 3, I'm going to have this dotted line. It'll be a little bit straighter. Okay, I'm going to have this dotted line here, meaning that this function here, when graphed, will not cross this line. So there will be something going on both sides of that, which is also called my vertical asymptote. There's something going on both sides of it, but they're not crossing it. So my domain is from negative infinity, because we always read left to right when we talk about domains, negative infinity to positive 3. And I'm going to put a parenthesis on positive 3 because we're not equaling it. We're just approaching it. I put a parenthesis on negative infinity because we can't stop infinity. I want to say it unions the other side of positive 3 to positive infinity. And that would be my domain. Okay, vertical isotopes. Again, we're going to take the function, and the denominator is what's going to determine what's the vertical isotope, because again, the restrictions is what causes us to either have a defined function or undefined function. So let's just go for it. Here we go. Let's find the domain of this function, and let's also find the vertical isotopes. So to find the vertical isotopes, I'm going to take the denominator here, set it not equal to 0. I'm going to factor this. So I do have x raised to the square here, so that means it's a quadratic. Remember, we have ax squared plus bx plus c, and whenever we factor, we take a times c, which in this case here is going to be 1 times 8, which is 8. And we take the product, and remember the sign here on C tells me if we add or subtract the product. This in here says we subtract the product, which is 2 times 4. That gives me a positive 2. So I know that when I write this in factored form, I'm going to lead off with x, and it needs to be a positive 2. So that means the 4 gets a positive sign, and the 2 gets the negative. Okay, so I got it in factored form. Let's set each one of these equal to 0 and solve, which again, it cannot equal, and subtract the 4 from both sides. So x cannot equal 4. And then over here, and solve. X cannot equal positive 2. So it's a negative 4. My apologies, guys. So it cannot equal that. So my vertical isotope is going to be when x is negative 4 and x isn't equal to positive 2. You see here, we draw the dotted lines at those points. And then what we're going to do is we're going to start, we always read left to right. And we're going to start here, and we know negative infinity to positive, or to negative 4, excuse me. And then we know negative 4 to positive 2, and then we know from 2 to positive infinity. There's something going on all sides of these. The function will not cross the vertical isotope, because therefore it would cause some kind of undefined function. So my domain, if I wanted to state my domain here, we're going to state it's negative infinity to -4 unions -4 to +2 unions 2 to infinity. Now, how are we going to determine how this function actually plays out without using the graphing calculator? Is you'll pick points right here. So you can pick like -10 when x is equal to -10 and when x is equal to -5. And what happens, we get these points going on, and as it gets closer to -4, you can see how it does this. And then let's pick how the behavior is between -4 and +2. So I could pick like -2 for x, I could pick 0 for x, and I pick 1 for x, and that gives me 3 points, and that tells me what's going on here, right, for y. So remember, whenever you plug in the function for x, it gives me back my y value, right? And then over here on this other side, I can pick +3 for x. Come back here. I can pick +3 for x. Sorry, my computer's just, there we go. I can pick like +7 and +10. And it's telling me what's going on this side here. Again, you just plug it back in the function. It gives you a y value, get it order pair, and you can plot it. Horizontal isotopes. Horizontal isotopes is where we get this horizontal line, this function, something's going on at that particular point. However, when you have the vertical isotope, the function will not cross it. A horizontal isotope, the function can cross a horizontal isotope. And let's talk about it. To solve the horizontal isotope, we ask ourselves, and I'm going to do some notation. Say I have f of x is equal to a times n to the n power over b times x to the m power. I'm just going to change it up a little bit. Now, if in this case here, if you're, let's talk about it. And we can go through here if you want to do it in this particular order. However, let's just say this first one says when the numerator and the denominator have the same power. What is this telling me? When my x to the n, that came from my numerator, when that power, n, is equal to the x from the denominator are equal, when the powers are equal, then that means we're left with the coefficients of a over b. What is a over b? That's the coefficients on that variable term you see over here. Now, if the numerator degree is less than, so here we go, if my x to the n, if that numerator degree n is less than the degree from the denominator, right? If it's less than, then that means y equals 0. My horizontal isotope is 0. However, if your power from your numerator, right, n, is greater than the power from the denominator, then there is no horizontal isotope. We have an oblique isotope, and we will talk about how to solve for one of those here in a little bit. So now let's talk about this one. What is the vertical isotope here? So that means we need to look at the denominator, because remember that gives us our restrictions. That also finds the domain. If we look at that and we say, okay, what is the vertical isotope here? We're going to have to do some factoring here to figure that one out. This one here, oh, my apologies, just ask for a horizontal one. Okay, well, the horizontal one, let's look at it. The numerator power here is 1, and the denominator power here is 3. So that tells me the numerator power is less than the denominator power, so the horizontal isotope is 0. And we'll solve the vertical one here in just a minute, but we could actually do some factoring to find where the restrictions is. Just remember the power here is cubed, so it's a little bit more work. This one said, what is the vertical isotope? Well, again, we look at the denominator, take it, set it not equal to 0, solve. that means we got square root both sides. Well, 0 squared is just 0. That means it can't equal 0. Then that means x equals 0 is the vertical asymptote. What is the horizontal asymptote? Well, if you notice, the power of the numerator is 2 and the power of the denominator is 2. They are equal. Therefore, we're going to look at the coefficients. So the coefficient on the numerator is 2 and on the denominator is 1. So I got 2 over 1, which is just 2. So my horizontal asymptote is y equals 2. And then, of course, when you draw this out on here, you don't want the function to cross at where the vertical asymptote is, and it's y or x equals 0, which is down the y-axis. And then we got 2 for the horizontal. And then you will take these XY table, plug in points on both sides of the vertical asymptote. So you pick some points here to, here you wouldn't pick 0 because it is the vertical. So you'd go out as far as -1 to get how it's going to play out. And this other side 1 to positive infinity, and we're able to graph it. And what do I mean is whatever points I pick here, I say x equals -10, I'm going to plug it in that function to get what my y value is, and then I'll have that order pair. And then I would plug in for x -1, get my y value, and then I'll have that order pair, and I can plot them. And then I'll do the same thing on the other side of the vertical asymptote. All right, here we go. It says find the asymptote. So to find the vertical asymptote, we just take the denominator, set it not equal to 0, solve, and that's where we get x equals 2 is the vertical asymptote. The horizontal asymptote, the numerator power is is 2, and the denominator power is 1. The numerator is greater than the denominator, therefore there is no horizontal, and we call this an oblique asymptote, and I might have spelled that wrong. We'll get to that. How do we solve for that? Well, when we're trying to figure out what that line consists of, we are going to do long division. So we can get that new, whoops, that's a minus. So I'm going to say x times what gets me x, 2x squared. So I'm going to say it's 2x. So now I got this. And then -2x times, or positive 2x times -2 gives me a positive 4x. And then we're going to subtract, which changes that sign. Goes to 0, leaves me with -7x, bring down that -1. Again, you'll say x times what gives me -7x, and we know it's -7. -7 times x is -7x. 0, -7 times, oh, no, sorry. My apologies, I haven't subtracted. -7 times -2 is a positive 14. And then we subtract, which changes this to a plus, changes to negative, so I get -15. So using long division, we can come up with a quotient and a remainder. You can do synthetic division if you wanted to as well. However, if you notice here, when we did that, we got what our oblique is. So our quotient, we're going to set it equal to y. And that's my oblique line. Here's oblique asymptote. That would give me my oblique asymptote. On this one here, our oblique asymptote shows to be y is equal to 2x minus 7. Double check to make sure that it's correct on the math. All right, so let's talk about occurrence of lines as asymptotes of rational functions. For rational functions, f of x is equal to p of x over q of x, where p of x and q of x have no common factors other than constants. Vertical asymptotes occur at any x values that make the denominator 0. Remember, because that causes it to be undefined. Therefore, those are going to be the points the function will not cross on the graph. The x-axis is the horizontal asymptote when the degree of the numerator is less than the degree of the denominator. Horizontal asymptote other than the x-axis occurs when the numerator and denominator have the same degree, and then the other case would be the oblique asymptote. Occurs when the degree of the numerator is 1 greater than the degree of the denominator. Now, there can only be one horizontal asymptote or one oblique. It can't be both. So you either have a horizontal or you don't. And if you don't have a horizontal asymptote, that means you have an oblique asymptote. Asymptotes is not part of the graph of a function. Okay. So crossing an asymptote on the function, we do not cross the vertical asymptote. However, there may be times you will cross a horizontal. Doesn't mean it happens all the time, but you can cross the horizontal asymptote. But no on the vertical. Graphing functions, it says find any real zeros of the denominator, determine the domain of the function, and sketch the vertical asymptotes. Find the horizontal or oblique asymptote if there is one and sketch it. Any numbers or any zeros of the function, the zeros are found by determining the zeros of the numerator. These are the first coordinates of the x-intercepts. So plug in 0 for x, we're going to find our y-intercepts, plug in the whole thing equal to 0, solve, it's going to give me my x-intercepts. Find functions, sometimes you're going to need to use points other than the intercepts. All right, so let's do this. So finding the zeros by solving the denominator, right? Because remember, that's going to tell me my vertical asymptote, that's going to tell me my domain, my restrictions on this, okay? So what I'm going to do is I'm going to factor this out. Now, some of you understand the factoring process. However, if you don't, we can always use the AC method. And what I mean, ax squared plus bx plus c, and then they could be minus. So we're going to take our a times our c, and that's going to give me my b. Okay, so in this case here, my a is 3. Remember, we're finding our zeros right now. A equals 3, B equals 7, and C equals 6. So I'm going to take 3 times 6, which is 18. And the sign on C tells me if we add or subtract. And since it's a negative sign on C, means we're going to subtract to get B, and B is a positive 7. So let's list it. We got 1 times 18. 2 times 9, and 3 times 6, and we need them to subtract to give me 7. So I'm going to mark out the first and the last. I know that 2 and 9 subtracts to give me 7, but I need it to be a positive 7, so it's going to be a negative 2 plus 9. I'm going to rewrite this formula. I want to bring the first term and the last term, put me some space, and I'm going to rewrite the middle. I'm going to put the 9 with the 3, but remember the middle has an x too. So I'm going to put the positive 9x here, and then the minus 2x down here. And what I'm going to do is I'm going to split this in half. So let me draw my line right here. I'm going to split this in half right here, and I'm going to look at each side separately to determine what I can factor out. And I notice I can factor a 3x out. And when I do that, that means I'm dividing each part by 3x. 3 goes into 3 once. X comes out of x squared, leaving me with x. 3 goes into positive 9 3 times, and it's positive, and x goes in x once. Bring down this negative sign. That means we're going to factor by that negative. And I notice 2 would also come out. So I'm going to divide by negative 2. Negative divides negative is positive. 2 goes into 2 once, leaves me with x. Negative divides negative is positive. 2 goes into 6 3 times. Now I'm almost done. I have this right here minus this here. So the parentheses are alike. So I'm going to factor out the x plus 3. That leaves me with 3x minus 2. And boom, that's how we get this. Now that we got that, I'm going to take the x plus 3, set it equal to 0, because remember, we don't really want it to give me an answer of this. So you notice I've been putting a line through there saying not equal to, subtract that. So my vertical asymptote is -3, meaning that that x cannot equal -3. If it does, it's going to give me undefined. Now let's solve this one. Let's say not equal to 0, add the 2. Then I got 3x is equal to 2, divide by 3. Now I have x is equal to 2/3. So that's my vertical asymptote. This means that on that graph, this function will not cross at x equals -3, and it will not cross it when x equals 2/3. So I also know that my domain is restricted at that point. So if I write my domain out, it's going to be -infinity to that -3, and it's going to union -3 to 2/3, and union 2/3 to positive infinity. So that means on this graph, there's all kinds of things going on from -3 to -infinity. Something's going on because right here, that function ain't going to cross -3. The 2/3, let's get approximately on that because it's not going to be exact. It's going to be like I'm going to say 0.7. It's a little over half. So I'm going to say probably about right here. Let's say about right there. Let's call that 2/3. It's a bad little representation because it's not exact. So let's say there's something, the vertical asymptote's right here. So then there is a function. The function is going on right here. A function's going on right here. And then a function's going on at 2/3 to infinity. Okay. Now to find the zeros of the numerator, so, okay, well, I found the vertical asymptote. I didn't state the horizontal. I guess we could do that right quick. Let's come back and state it. Horizontal, the numerator, power on the numerator is 1, and the power on the denominator is 2. So the numerator is less than the bottom. So therefore, y is equal to 0. So here, let's see if I can just change it right quick. Right here, we'd put the horizontal line for the horizontal asymptote. Now let's talk about finding the zeros again. So now if I said, let's let x equal 0. If I say that, that means everywhere I see x in the function, I plug in 0. And what do I get final? So I get 2 times 0 plus 3, which is 3. 3 times 0, 0, plus 7 times 0, 0, minus 6. So that leaves me -6. And then we divide it out, and now I got a -1/2. So that order pair, because I plugged in 0 for x, that order pair is 0, -1/2. So that's where it's going to cross the y-axis somewhere. The function's happening there somewhere. And as you see, yeah, looky here, it shows where we got our y-axis here. We have our vertical asymptote, oops, started line here at -3, and vertical asymptote at 0.7. I'm just rounding, you know. And then we have this function going on both sides of it. All right, moving on. Poles of the graph. All right, well, again, we still have to find what's going to cause this restriction here. Remember, because you can't have denominator here, so we're going to factor it out. We're going to set each parentheses equal to 0. And as you notice, when we do, it gave us a statement in this notation form. So that's a set builder notation. All it's saying is that x cannot equal -1 and x cannot equal 2, +2. Because if it does, then I get 0. If it equals one of them, if not both, it gets 0 on the denominator, and therefore we don't have, it's undefined. We don't have a function going on here. So my domain could be written as the set builder of x that builds on when x is not equal to 1, and x is not equal to 2. So that's a set builder notation. Also is written out when we draw that on the graph, a horizontal asymptote is -1, right? So we have this dotted line, means this function's not going to cross there. At to +2, it's not going to cross there. So I know on this side, I get negative infinity to -1. Here in between, I got, it's going to union -1 to 2, union 2 to infinity. So we got stuff going on both sides, on all sides of the vertical asymptote. And here we go. So if I wanted to find some of the values, that's where I would say, oh, I'm going to pick points on each side of the vertical asymptote in order to determine what's happening there. As the graph opening upwards, downwards, is it above the y-axis, below the axis? You know, so to get a good idea, so you start picking those points.